Hello and welcome to In the Making, a series of conversations from North Bennett Street School where we connect with a range of new voices, fields, and perspectives. Before we get into our conversation, we want to thank the many supporters that make our programs possible, including the Massachusetts Cultural Council, the Holt and Bugby Company, and all of our corporate partners in craft. My name is Kristen Odell. I'm an NBSS staff member and host of In the Making. When thinking about the work done here in this building, using our hands to build and repair objects, robotics rarely comes to mind. Yet many of our tools and essentials are manufactured using robotics. Recently, I read about a manufacturer's attempt to bring craftsman tools back to be made in the US. This company built a massive factory complex which relied largely on state-of-the-art robotics to manufacture our staple tools. Think socket wrenches, crescent wrenches, that type of thing. For a variety of reasons, it did not work, but a theme throughout and our stake in this conversation is the role of people in this process. People with material knowledge and understanding of a tool's function. As Nick Boston here has said before, you have to understand what you were asking the tool to do. In his case, it's the hand plane, and we'll get into that in the program. With us today is Julie Shah, professor of robotics in AI, robotics and AI at MIT. Thank you, Julie, for being here. Paul Reidt, founding principal of Kochman, Reidt, and Haigh Cabinetmakers, right here. And Nick Boston, a cabinet and furniture making soon-to-be graduate in our cabinet and furniture making program upstairs, student and tool maker. And these are all of his beautiful tools, and we're going to get into the connection that he has with his hand tools. This is such a broad topic and a really great group to discuss it with, many shared and strong feelings around this. And we're going to start with Julie. Julie, you specialize in the brains and software used in robotics manufacturing. From your professional perspective, what are your thoughts on robotics making our essential tools?
Yeah, thank you so much. It's such a pleasure to be here and to be in conversation about this, and also to be able to learn from you. So my area of expertise is robotics, and specifically like the brains and AI for robotics. I don't build tools, but I started my career working out at Boeing in the assembly of large commercial airplanes, and developed a deep appreciation for the expertise and sort of the human endeavor involved in building up an aircraft, and the challenges of bringing robotics in to support that process. And so the vision behind what my lab does is we aim to develop the intelligence for robots to make it easier to be able to harness the relative strengths of humans and machines. And so if we think of the robot as a tool in and of itself, the goal is to make the robot accessible and easy to use for those that have deep domain expertise in an area, but are not necessarily trained as robotics engineers or programmers. And so the goal is to use AI to help facilitate communication and use of the robot as a tool. And it's, by and large, it's very, very difficult to make robots work in many settings. I think only one in 10 manufacturers even has a single robot. And so one of the aspects we study is, the success stories in firms that are able to scale use of robots in ways that not only improve productivity of the firm, but improve quality of work and are sort of empowering to those that bring the knowledge and expertise for how the work should be done. And what we've seen over and over again is something that differentiates the success stories in the use of robots, or what would not be a success story is, in the case that you're referencing here, is the extent to which those robots are developed and implemented in collaboration with those with domain expertise, bringing very human-centered approaches that leverage understanding of the process in the development of implementation of automation and robotics. And so I'm very excited today to learn more about making tools and what might make that process, amenable to support and augmentation through robotics and AI.
There's a lot of perspective here, so this is great. What about one of you from each of your professional perspectives? What are your thoughts? What's your first thought on robotics making an essential tool that you use every day?
Well, it's an interesting question because I mean, it's something that I have not thought about a lot, to be honest with you. And the reason for that is that that is kind of a meta level of making. So we utilize tools in my business of all kinds, simple hand tools that have been around for centuries, as well as sophisticated digitally controlled equipment. And I assume that many of the tools, whether they are simple and primitive or whether they're, digitally controlled tools, may have robotics in their manufacture. In fact, they probably do. And yet, if the question is, do I think that's okay? It's yeah, whatever it takes. I think it's fine. I think the article that provoked this conversation was an interesting study about what needs to be designed into a tool that's making a tool. And one of the most interesting failures from that story was the fact that the people with what you might call the traditional material knowledge of what they were trying to create were not as enough part of that process. And that was, to me, the most interesting feature of this question, which is that as robots become increasingly important in producing things for us, mostly that is because of labor saving and the benefits of automation. But the fact is that they need to be able to actually learn. This AI makes so much sense here because anybody who uses a tool is in a constant state of learning about the material that they're working with, and they're also the experience is changing them as well. So if a robot that's making something, whether it's a tool or anything else, isn't learning from what it's doing, it's completely deficient compared to a human being making it.
Great segue into Nick giving us firsthand perspective on the value. Where do you see the value in building your own tools from start to finish? And maybe you could start that with telling us what was your first cue to do so.
So my kind of interest field is specifically hand planes. Originally I just thought they were cool. I wanted to make one that worked myself, and I wanted to do it all with my own hands. That's where I got this one. And it worked really nicely. It's just horrendously uncomfortable to use.
Wait, it has a name.
Oh, the potato plane.
The
I call it the potato plane because it's very lumpy and not very comfortable.
Yeah.
And as kind of a continuation in curiosity, I wanted to see if I could take this and make it comfortable to use. So that's where I ended up with this one here. It's much nicer to hold, and actually do use this on projects, even though it was just kind of a curiosity thing. Around a year ago, what I actually noticed, since still the most of my planes were predominantly metal planes, is I started actually having trouble with the weight, with how much I was using them. I started having nerve tension issues in my upper body, and so I wanted to see what's my alternative, because I really enjoy having my hands directly on my work, and being able to feel that feedback. It's really important for me. So I didn't want to lessen my usage of hand planes. I just wanted to see if I could change that. And that's kind of where I ended up going with these, is just I wanted a plane that was lighter, that I could use for longer periods of time without running into issues. And I think I succeeded. I think this does quite a good job. If you'd like to compare the weight.
Yeah, the weight is a huge difference, but I want to settle on this one thing relating to this one. So none of these, this plane that we're using as an example, there, some pieces were machine made, obviously it's metal, but we don't know what, robotics were used in this particular plane. But I want to make the point here of this handmade plane that you made from start to finish. What is a difference in the, one mechanism in this machine, in this big box store plane that you can compare to this one? And I'm trying to get to the point here. It was how you move this. And yeah.
So with the wooden planes, it's a little bit of older tradition and some newer construction. But to adjust the blade in modern planes, you have the knurled thumb screw here, which adjusts the depth, and then you have a lever here on the back, which adjusts the angle of the blade. And with wooden planes, it's pretty simple. It's just all done with a hammer and hammer taps. So to adjust it laterally, you just tap on the sides. And then to adjust it for depth, you just tap on either the back of the blade or the back of the plane to retract the iron.
So the reason that I wanted Nick to share that anecdote is that we're getting into the weeds on that disconnect between that we might have with our tools that are made in a robotics capacity versus making them ourselves. This is a literal example of being able to feel, moving that blade over, as opposed to this sort of mechanism in this plane where you can't even see what it's doing. It's a different type of detachment from what the plane is supposed to do, if that makes sense.
One thing that I've noticed, and anybody that works with woodworking equipment knows this, which is that there's this constant effort to increase the precision of the tool. And for hand tools, the precision is largely in the hands of the user, like a plane. And so there's a whole dimension of very fine motor skills, of eye-hand coordination, of also understanding your material. When you look at a plane, or when you're looking at a piece of material that you're going to use your plane on, you're going to look at the pattern of the grain and understand from experience the direction that you might have to move the plane, or how deep you can set the blade. Those are very human physical interactions with a tool. And in fact, I would say that it's probably impossible even to communicate some of the adjustments that you learn over time as you become more adept at using your tool, which this is also about robotics being able to learn what they're doing. Or, I think, Julie, you were mentioning this new lab, and when you mentioned it, I think I must have read a little description of the effort, and the description that I heard was to create a robot that could observe, learn, and then implement. And that is a complete recapitulation of the way humans use tools. They observe, they learn, and then they implement. And without that sequence, the tool can only be tuned to do something repetitive without much sensitivity to its workpiece. And that's a critical issue, I think. And it's even more interesting to me when you talk about the planes that you have created here. You have started to address different features that apply to your experience of using them. This one was too heavy, or this one didn't fit your hands properly. And so the tool itself evolves according to the user's needs and physical characteristics. So that's another sort of very human adjustment that is a matter of billions of calculations that are going on in all of us at every second when we're doing any kind of manipulation.
We want you to feel a weight difference here. It's huge.
Yeah, and sometimes that's okay because you want momentum. If
Yes.
you're like going against a heavy resistance, and
Yes.
you're going to make a greater effort, but you're going to have the momentum that will give you a better bite out of what you're, and yeah, these are completely different.
Yeah.
And you might have a need for this one, even if you, in many cases, want a lighter weight, for control.
I haven't gotten rid of my metal plates.
There you go. I mean, that makes the example. But, we started talking about the effort to make Craftsman tools in a completely automated way. And, in effect, it reminded me of the old Industrial Revolution where, remarkable machines were created to do one very precise thing and had no flexibility whatsoever. They just did one tiny little thing. And, digital information has changed that a lot. Now it's made like the machine that we use all the time, our CNC router. It's a very simple machine. It's really just a spindle, but the digital control makes it incredibly flexible.
So let's take your cue for this question for you specifically to your profession. Living in a sea of design conformity, thanks to all of the home reno shows, DIY movement, social media, everything looks the same. So how have you, Paul, married technology of AI, if you're using AI, I know you use SketchUp, with craftsmanship and your design and furniture making cabinetry practice?
A good example, well, this dovetails exactly with what we were just talking about a moment ago. I'll give you a very specific example to answer that question. We were working on this wonderful house in Gloucester, and the owners were very ambitious about design and very open to unusual design ideas becoming part of their home. And they also had a fondness for Art Deco, which was just the wonderful flourishing of American design at a moment of exuberance. But anyway, beside from that, because I knew that we had this CNC technology in the shop, I designed things that would have been not impossible to make, but impractical to make without that equipment. And so it actually made possible the generation of design ideas. It made them plausible I mean, the idea could have existed, but the need was to have something that could actually be manufactured in a reasonable way. And our CNC equipment was there to do it. And, one time during that project, I was in New York City and I saw this remarkable sort of pattern on a deco building, and I recognized its application for one of the details in this project. And all I needed to do was draw it accurately and give it to the CNC guy, and he, and it was very simply made. And making it with a fret saw, for example, which would have been the traditional tool, would have been so time consuming that I never would have, the idea would have never taken life because I knew it would be too impractical.
Right.
So I think this, in some ways, this technology has spawned a flourishing of ideas of design that actually works against what you mentioned. The idea that everything has to look the same. That's a relic of the machine age of Industrial Revolution, where machines just did one very specific things.
Yes.
And mass production started then.
Nick, on your planes, can you imagine, and have you incorporated any digital technology, AI, in any sort of cutting of your shapes or design elements?
Well, so I am definitely not very versed with CNC technology, using a CNC router. I've been exposed to it, but not my area of knowledge. So I am actually talking with another student who has a laser cutter about doing designs and templates and stencils for my shaped components, because I do all the shaping by hand. And it would be nicer if I had more accurate guides or templates to go off of for my shaping.
So just for accuracy, that's what, and that makes sense. I mean, templates are great, precision is great, but really, I mean, for the shaping piece of it, I mean, that's part of making this for yourself is shaping it by hand, right? I mean,
Yes.
I'm assuming that.
For me personally, I don't think that given the option, I would want to implement like a CNC shaping for the tool itself. I find that I really enjoy the hands-on approach, that I can feel it at every step and see how it's developing over time. I really appreciate that. But I think it's I'm also not opposed to it.
I'm gonna take this into your plans again. And this is this existential question that I had for both of you who use tools. And Julie, if you have an example of how this relates to your life, please share it. What would you say is the most important piece of the relationship between you and your hand and that essential tool? Nick shared some awesome thoughts with me before about, just when making one of these tools, what is the most important piece of that relationship as it's an extension of your hand? I mean, you talked about feedback and just the physical weight of it.
Yes. So the starting issue with this was I just couldn't use a metal plane for as long as I needed to accomplish a job. I wanted a lighter plane so that way I could use it longer to get through more of my task in one sitting. I think that is definitely one of my driving factors with trying to come up with a design for it, is have it be ergonomic enough where you can use it for long periods of time, as well as I do like the aspect of the lighter plane in terms of the feedback you feel from the wood if you hit a patch of reversing grain. It's in my opinion easier to feel that with the metal or with the wooden plane than it is with the metal plane. Whereas the metal plane has the benefit of it won't bog down that.
Yep. I know we're getting granular into the specifics of a tool, but it's just telling that story of the importance of that material knowledge and the connection as we use our tools. They are an extension of our hand, they need to work in the way we need them to work.
One thing that I've talked here at the school about a lot is I'm on the board here, and so I get to have these conversations about the direction that the school is taking, and there's an ongoing conversation about sort of digital technology being brought to the school, and the school, while its mission is to teach traditional craft, it also is part of its mission to prepare people for vocations inside the craft. And now, if you graduate from your program and you go into a wood shop, and the wood shop gives you a great opportunity to make a living, they're going to have CNC equipment, for example. And so one thing that I've noticed in my company is that we have developed ways of using our CNC equipment that most shops don't do, and that it looks like we're very busy writing code and programming the machine to do what we need it to do, and of course that's very much involved. But the person that is there figuring out how to use this machine is a very experienced woodworker, because you need to know material qualities that you're addressing. And we're talking about establishing tool paths, RPMs, sequence of operations. All of these things relate to the material at hand. And it may be that different kinds of wood will require different, it depends on tissue structure of wood. It depends on whether it's plywood or some kind of fiber material. But those are the experiences of a woodworker. And so when there's this notion that, for example, that CNC equipment doesn't require woodworking knowledge, it requires more technical, knowledge with computer operations or writing code even, it's not so. It absolutely, it's useless in the hands of somebody who really doesn't know the material.
And
It
Julie,
makes a difference.
this is what sparked this whole conversation. Julie understands more than anyone. I'll quote you. It's really easy to undervalue the judgment and experience that someone brings to what seems like a fairly simple task. And by simple task, I'm assuming it means running a robotics machine.
Absolutely. Yes. I've heard and seen the same thing from shops that are manufacturing parts for aerospace, for example. The experience and judgment and understanding of like the RPMs, the material, the design of the program so that it can produce, very, very difficult to manufacture geometry. It's very easy to underestimate it and just look and see. All you see is someone programming a machine. So what's required to do that is knowledge of how that machine is programmed. But it's in other contexts, I've definitely observed that is not true, and is one of the main sort of gotchas that can really really stand in the way of making use of a new technology in a way that can really expand human capability. And just reflecting on what you're describing here, the sort of feel and the sort of tacit knowledge that you gain through doing your work. It's very difficult to capture that in a digitized format and translate that for a machine. I say very difficult because academics never like to say impossible, but on the flip side of it, the example of using CNC to be able to explore new designs and create something that you might not have otherwise. Like, these are the ideal examples of how you think about harnessing what a technology brings with what you bring with your deep expertise in an area. And like, that's the model in my view. How do we replicate that type of understanding and exploration with technology at scale? But it's not as common as you would think. And so it's just very heartening to hear about the very creative ways that you think about working with technology and how it enhances what you do.
And Julie, I remember you saying that you've said scale a few times in this conversation, and you've said this to me before, that the successful large companies who have implemented robotics in manufacturing, it really is all about scale, where it's phasing in these systems to complement the existing human workforce. Is that what I've heard correctly?
Yeah. So I think it is good to like pause and think about what is the goal? Like, is it scale? And in the areas that I work, the goal is not necessarily to replace human labor. In manufacturing, there's like 700,000 job openings. There's the goal is not to supplant human labor, but to be able to augment it, so that firms can grow, quality of work is improved, and wages are improved as well. Economic security is improved, and it's not guaranteed that you achieve all three of those things. But the question is, what decisions do you make, and how you acquire technology, how you implement it, and how you work with it. What organizational decisions do you make? What management decisions do you make that can sort of achieve that sort of win-win-win for everybody? And it can be exceedingly hard to do. And unless you're working side by side with those that understand the process and understand their nature of their work and how it can be improved. But I'd like to roll back my comments and say, I think more broadly, like, scale isn't necessarily the success criteria. I sort of have that mindset from the manufacturing sector, where it's a competitiveness issue to be able to bring these technologies into firms and achieve those positive outcomes. But I think in your case, scale isn't the goal, right? So the question is,
right.
what does augmenting mean? What are the dimensions of augmentation, and what does it mean to you? And I'm getting a better sense of that through this conversation.
Yeah, I think when I was thinking scale, mostly from the perspective of sort of, and maybe I'm probably using the wrong word, but phasing in these systems to be sent in a sensitive way to your existing workforce. We visited Starrett Tools. I'll discuss Starrett Tools for a second. Very old manufacturing precision tool company in Western Mass. They've started incorporating robotic systems. I don't know when, but they're doing it in this very sensitive human forward way, where they're incorporating them into these shops where their employees have been running these shops for, they've been working for Starrett for 50 years. So in that way, it's the responsible sort of phasing in of these robotic systems, as opposed to just building a multi-million-dollar plant with like just robotic systems.
Yeah, absolutely. Another aspect of the conversation that's really struck me is the spirit of experimentation and learning that's so human, but that's just like a continuous part of the work that you do. And the way robotics cuts against that is you do typically program a system, and then like the goal is to set it and forget it. And it really, in the way we design robots and use robots, it really impedes that exploration process, that experimentation process. And, I think you see that as at an individual level, but, or other larger scale organizations have that same sort of experimentation and learning process. So in factories, there's well-defined curves for sort of productivity improvement of an assembly line when it comes online. And that that learning curve, it's like a human driven process. It's people that are, could never think of the ideal way to sequence a set of operations and, design for manufacturing in advance, but through process improvement and continuous learning, the human endeavor, the organization learns and improves. And robotics, largely the way we use it today, like cuts that learning curve. So once you implement it, like that's where you are, that's it. And you lose the opportunity to be able to leverage that the human insight and innovation.
There's a dimension of this is I'm trying to remember where I read this. Oh, I know what it was. So I remember hearing that this, I don't know if it was an anthropologist or some, there was some effort to define what makes humans uniquely human. And there was this one category of homo faber, man the maker, and that making is the critical defining characteristic of human beings. And reading through this, there was what was called creative material engagement, that it was a sort of way of identifying the process of making something. And the critical term is creative. It is a process that is always inviting discovery. It's not static. It's not set it and forget it. That's kind of what learning is. It makes room for discovery of something that has never been experienced before, that can then be incorporated into a process. And I noticed this in my own shop. It happens all the time. There's probably 25 people on the shop floor. It's a smallish environment. People see what other people are doing. People share ideas. There is this constant process of engagement and invention and improvement. And it's a very fast evolutionary process. It's like taking natural selection and just sort of putting it on the fast lane. And robotics, to be successful in sort of being implemented into this process, this is your job, Julie. Figure out how to make them learn and invent.
Well, it's our job, because I don't know how to learn and invent what you do. So that's why it requires collaboration.
Well, let's stick with you here. Where does this all go? What does the future look like for our tools?
Yeah, I mean that's a great question. So, from the conversation, another thing that that strikes me with robotics that makes it very, very difficult to work with, and an impedance to the magic that you bring to the work that you do, is unless you're going to invest, like, order hundreds of thousands or millions, arguably, of dollars. A colleague recently gave me this line, so I've been using it. If you look at, like, the dexterity, the dexterous capability of robots today, unless you're investing at a very high level in a very specific process, you're kind of working with something that can do anything you can do with oven mitts. So I'm just wondering, for you, you're
What's the
tell
threshold
me
of
what
what we
you
can
do
make
with
with
your
oven
oven
mitts?
mitts.
That's funny. I just want to ask our guests, some of my tech here has dipped out, so I may have lost some of your questions, so just please take them back in. But one person has asked what these tools are, and we'll just show you. I mean, these are Nick's handmade hand planes. This I'll show just because this is a tool that I sell in the store. That's another great example of human material knowledge in tool making. This you just see as a pry bar that you'd buy at a big box store. But this is specific to preservation work, and our preservation carpentry community live or die by this. And the reason is the steel is a certain way, a certain superior quality. This is a certain size here. And more importantly, these points come to such a fine point that they can remove excess without damaging critical material that they're going to reuse in a rebuild or something of that sort. So great Svedbro pry bar, blue bar. I sell them. They come in all sizes. Great example of material knowledge in tool manufacturing and tool making. And then yes, these are Nick's hand tools that hand planes that he's made.
Yeah, hand planes are nothing more than a blade held at an angle with a reference surface. These are just two different ways to go about doing that. This one's made of wood, this one's made of metal, with more modern manufacturing techniques. If I were to remove the blade, it's really just wedged in with another piece protruding through an opening on the bottom. You'd use this to dimension wood, fit components, smooth the surface in preparation for either finish or sanding. And they serve the same purpose, they just look a little different.
Mm-hmm. One of my favorite sort of somewhat frivolous but also really fascinating points to this story is about how technology has affected our problem solving and critical thinking abilities, and how I can use that idea around this tool situation. We live in a one and done tool. If we want something, one specific tool, we can go to the big box store and buy one for $4 that was probably manufactured using robotics, and we can throw it away and nothing, no harm done. So these ideas that affect, technology affecting our problem solving and critical thinking abilities, and how we think this disconnect to our essential tools has a larger effect on our daily lives. That's a big one for me here.
I have an observation about that. There's this wonderful term called bricoleur, which is roughly translates as tinkerer. But what it really means is having the ability to use something as a tool for a way in which it was not intended.
Oh,
And so
we have a lot of that around here.
yeah, I mean, that's part of that sort of creative imagination that goes along with making and using tools.
Mm-hmm.
And the fact is that if there is a tool for everything and it's always available, that kind of creative imagination will not be exercised. Mm-hmm. That's a form of invention that would just wither. I mean, and it's not the case, but you know, I see these things all the time that are like Swiss Army knives, where it's supposed to be every tool you need in one little package.
Yep.
And if you had a complete Swiss Army knife, you know, you would not become a bricoleur. You would never use that form of imagination. Wouldn't need to.
Mhm.
And invention would suffer in general. So that's my answer.
I like
I think
it.
it
Yeah.
would suffer.
It's great. We have an example of, Nick was telling us about sort of a big box saw that, a panel saw that we, of course, our students use because they're starting out, it's the best economical route to go. It's probably, stamped out by, a robotic system in some way. And you can explain to us why it's one and done.
Yeah, I do have an example. I don't think this one's
It's not a good example.
it's not the best example, but if you needed a saw for one project, you could go to a big box store and get a saw that has impulse hardened teeth, where they just harden just the teeth to beyond the hardness of a file, which is what's traditionally used to resharpen saws. So what that does is it kind of turns it into a throwaway tool, where once it's dull, it'll stay sharp for a long time, but once it's dull, the effort it would take and the tool requirement it would take to resharpen it is several times more valuable than just getting a new saw.
Mhm. And I'll squeeze this in the middle. We learn here at North Bennett to sharpen our own saws.
Yes,
Yes, that's like number one. I mean, that's what you do up there, right?
it's one of the earlier teachings to maintain our tools and have that,
Mhm.
You know, there's another dimension to sharpening, which any of us who have tried to put a perfect edge on a chisel, say, or a plane iron, it is a remarkable exercise in focus, control, eye-hand coordination, fine motor skills. You know, this is a very immediate sense of physical engagement with something and I've seen people evolve different sort of techniques for holding or supporting. You know, I have to say that in our shop, most of the blades and router cutting tools are sharpened by machines. But every woodworker in the shop knows how to keep their plane irons and chisels sharp. Some are better than others. I mean, it's amazing how fine a technique it is to put a good edge on a knife or a plane iron. It is not a small matter, and it takes years of experience to get there.
Mhm.
And when I see it happening here at the school, it's almost like there's this little quiet temple of the sharpening stones and the focus that I see people applying to that task is
It's
amazing.
Violin.
Yeah.
Yes,
yeah.
yes. You brought, when you first arrived here today, you brought up the human origin connection to tools. And that's also where I'm going with that question of how this disconnection from our tools affects our critical thinking and problem solving and just our tactile world, when you can just grab and it's not a great example because a socket wrench is a socket wrench, but when you just grab one and you have it in your mind that you have no use for it beyond this, you have no connection to it. And so how does that affect our greater existence if we're losing that connection, that tactile sense that we need?
When the Industrial Revolution was in its infancy, Karl Marx talked about alienated labor. The idea being that as things became mass produced, nobody owned the production of anything. There was no personal sense of authorship anymore. This was something that had belonged to making forever in human experience, and it was suddenly broken. And now I think most people don't have any sense of making at all. You know, if you need something, you don't make it, you go get it.
Mhm.
Somebody else made it. this alienated labor has happened.
Mhm.
It's a huge cultural change since, I don't know, 3 or 4 5 generations ago.
I think my I guess everyday example is my car and my friend's car. My friend he works on cars as his passion. He and his dad, that's what they do together. But they work on older cars. My car, if I open up the hood, it looks like a spaceship inside. I wouldn't have the ability to take it out. It has to be manufacturer serviced. So my friends, they get to they have that inner knowledge of how their car works, how to fix it. They have the ability to do that and go in. So I think it kind of plays into that tinkerer and right to repair aspects of technology, where as things get more and more advanced and specialized, what do each individual person, what can we still do?
Well, my bigger question there is, do you wish that you did have,
Yes.
or do you just rule that out? Like, no, that's not, I like to focus on this piece of tinkering in my life. Or do you wish that your car were something that you could open the hood and be like, okay, I get all of this, I'm gonna fix it?
Both. I enjoy working on hand planes. I enjoy tinkering with hand planes. But I also I wish that it wasn't so much a requirement that if I have a problem with my car, I have to send it back to a dealer for them to tell me that this one $2 little clip just fell off.
Think of how much that diminishes your sense of agency in the material world we live in.
Yeah.
Exactly.
Yes.
You feel helpless. And it's kind of withering to self-esteem to think that the things you depend on every day are beyond your ability to influence.
This is what I mean. This, and Google Maps was my easy layup example. I mean, the fact that we all 1000% rely on it now. When
Nobody knows how to find their way anymore.
Yeah, it's crazy.
Yeah.
I have a question that someone, I think this might be for Julie. Are there ways to use robotics that don't lose the more appealing aspects of working by hand?
Yeah. To the comments you were just making, I teach in the aerospace department here at MIT, and a number of years ago, a colleague made a comment to me that a few decades ago, you could rely on the students coming in, and they would have been disassembling their cars, and they knew with their hands what a carburetor was, and when you talked about a piston engine, like it made physical sense to them. And that our students, don't have that anymore. And the way that manifests for us is that you give them a problem to solve, and they might make a small mathematical error in getting to the end, but the answer is nonsensical. And if you had a more intuitive understanding of the physics and the system, you would be able to identify that. But when you're just relying step by step on the mathematics, and you have an error and you get to the end, and you can't sort of bring that broader judgment to understand what the answer means, it's a really big problem. And so I think we see that in many aspects of our lives. Another one is thinking about pilots in the cockpit, working with cockpit automation. This is an example I go back to frequently because I learned a lesson the hard way that you really can't fully train someone just to work with the technology. It requires understanding how to fly the plane and also working with the technology. And the fundamentals of flying the aircraft need to be honed independently, and then in conjunction with working with the technology. Otherwise, you're not in a position to do the job that you need to do when something goes wrong. But we can't all be experts in every aspect of the complexity of of what we have in our lives. So the question is, where do we focus our efforts to develop the expertise that we really truly need? I think it's But where we need it, it's you really have to roll back and go to the fundamentals. I think in machine shops, we hear the same thing as they're building up expertise for working with automation and robotics. The training programs all have to start with like basic 101 in machining. You can't jump steps. And so, you know, I'm a big believer in training from the fundamentals in whatever you're training up in. Yeah.
What do makers, this is a question for the makers and I think for everybody. What do makers lose by using automation, and are there ways to get some of those things back? What a rich question.
I think the hands-on aspect is definitely a possibility. I think in your shop specifically, I know you were talking about that you said you hadn't actually done any of the shop work for a while. It's not automation, but you're kind of ending up removed from that process a bit. You know, if you imagine you replaced your shop team with a fully automated assembly line of some sort, then I feel like that's even another step back.
Yeah. The engagement, human engagement with the made object has many, many, many dimensions that I think are disturbed or lost by the implementation of automation. And we've been struggling with this over time. I mean, everybody who is trying to make something. Now, in my personal case, we don't make a product. We don't make the same thing all the time. We make a different thing for every customer. It's custom. It's made to order stuff. And that's, I think, because of that experience, there is less ability to automate what we produce. That being said, I already spoke about the remarkable introduction of flexibility and control that digitally controlled machinery provides. You know, that was a sea change in woodworking when CNC equipment was able to be programmed to do one thing, to do a one-off. You know, that was kind of a term of a one-off, which to everybody's mind meant, oh, you have to invest so much time to get it done.
Mm-hmm.
Now, CNC can do a one-off as effectively as it does 1,000, 100,000 of the same thing. So that's in that sense, automation has increased. I don't know if you call that automation. I mean, if by automation you mean mass production, then that's a different question.
Yeah.
But if by automation you mean, you know, a more sophisticated tool that has digital controls, it increases flexibility.
Mm-hmm. And with that, thank you all. Thanks so much for being here with this awesome, rich conversation. And thank you to our guests for spending this midday with us. It's been really great. Julie, thank you so much for spending your time with us.
Thank you so much. I really enjoyed it.
Yeah, and Paul and Nick, it's been really a treat. Yeah. Thank you all. Take care. Take care. Have a great day.
I really enjoyed that, I must say.
I learned so much from it. Thank you so much.